Hi everyone, happy Wednesday. Again, we're halfway through the week already. It is May 5th. I hope you're all doing well. We are going to finish scatter plots today and do day 2 of scatter plots. So your goal today is to learn a little bit more about some correlations in scatter plots. So when I say the word correlation, I mean that scatter plots can have a positive, negative, or no correlation at all. Okay, this first graph is showing what I would call a positive correlation. The second graph shows a negative correlation. And then this third graph shows no correlation at all. Okay, now what does that really mean to you? Okay, with a positive correlation, you will see that the graph itself looks like it's going up from left to right, okay? And what we would typically say is that as x increases, y also increases. Okay, now we could say that as x decreases, y also decreases. Okay, so what I mean by that is if the size of something or if a number is going up and the other set of data is also going up, it has a positive correlation. Or vice versa, if one item is going down and the other is also going down, that's a positive correlation. So here's an example of that. Let's take the amount of time you spend studying and your grades in school. Okay, as you study more, your grades will typically go up. The less you study, your grade is probably going to go down. So because they're both going up or both going down, that's a positive correlation. Okay, the next one is a negative correlation. So as x increases, y decreases. Okay, now the best example I can think of for this is a candy bar. Okay, as the size of the candy bar increases, okay, the number of candy bars that I can eat decreases. So if you just have those little bite-sized candy bars, I can eat a lot of those. Okay, so the size is very small. The number I can eat is big. Now, as the size goes up, I make a larger candy bar, the number I can eat goes down. And if I get a king-size candy bar, the number I can eat goes even further down. So notice that my thumbs are going in opposite directions. And when they're going in opposite directions, that's a negative correlation. And then the last one is that there's no relationship. Okay, there's just no correlation between the two. This might be something like your shoe size and your golf score. So as your shoe size increases, what happens to your golf score? Well, who knows? I don't think that my golf score would have anything to do with my shoe size, unless of course I have like clown size shoes and they get in the way when I swing, but typically not the case. Okay, so let's try a few of these and see if we can figure out the answers. Okay, so we just want to be able to say positive, negative, or no correlation. And this is what you're going to have to do on your homework tonight also. So you're going to read a statement and then tell what the correlation is. Now, I find it very helpful to do the thumbs up, thumbs down type thing. So if you're watching me on the video, you're going to see me do that. Okay, so the first one, the size of a jar of baby food and the number of jars a baby will eat. As that size of the jar gets larger, okay, if we have a very small jar of baby food, a baby can probably eat a lot. But as I increase the size, the number of jars that a baby can eat goes down. So therefore, we would say that that has a negative correlation. Okay, the next one, the speed of a runner and the number of races she wins. So as a runner gets faster, as that number is going up, what can you say about the number of races she's going to win? Well, most likely, the faster you are, the more races you win. So again, both are going up. So that would be a positive correlation. Okay, the next one, the size of a person and the number of fingers he or she has. So think about that. A baby, typically, a baby has 10 fingers. as the baby gets bigger, okay, now they're a 10-year-old or now they're a 12-year-old, what happens to the number of fingers he has? Well, I don't know. I'm like 39 and I still have 10 fingers. Okay, so that hasn't changed. So there is no correlation. Now I know some of you are thinking, what if somebody lost a finger in an accident or something? Okay, we're talking about the typical person here. So let's not be ridiculous. Okay, the next one, letter D. The population of a state and the number of representatives a state has. So you have to think social. Okay, you've probably learned this from Miss Sockery or Mr. Hoyt. So as the population of the state increases, as that goes up, what happens to the number of representatives? Okay, the more people in a state, the more representatives they get. So both are going up. So that is a positive correlation. All right, let's look at letter E, the temperature outside and the number of people at the pool. So think about this one. As the temperature outside increases, it gets warmer and warmer and warmer. What do you think is happening to the number of people that go to a pool? Well, my guess is that you're probably going to get more and more people there because it's warmer out, more people will go. And if it's colder out, the temperature goes down, less people are going to be there. So both thumbs are going in the same direction. And if they're both going in the same direction, that is a positive correlation. Okay, the next one, the length of a movie and the number of times it can be shown in a day. Okay, I'm going to put this one in a kind of chart over here to show you the length and the times it can be shown. So let's say that a movie is 1 hour long. In one day, it can be shown 24 times. That if we have a movie that is 2 hours long, that means in one day it could be shown 12 times. If the movie is 3 hours long, it could be shown 8 times. If the movie is 4 hours long, that means the movie could be shown 6 times, and so on. So if the movie was 12 hours long, it could only be shown twice. Okay, so from this table, you can see that as the length of the movie goes up, what's happening to the number of times it can be shown? One is going up, the other is going down. Now my thumbs are going in opposite directions, so that means it's a negative correlation. Okay, the last one, a person's height and their birthday. Now, I don't know about you guys, but I don't think they have anything to do with each other. So I'm going to guess that it's no correlation, but let's kind of discuss that one. So how tall a person is. If you're born on May 4th, does that mean you're going to be short? And if you're born on May 5th, you're going to be tall. May 6th, you're going to be somewhere in the middle. So as the birthday goes up, no. Okay, there's just no correlation between your height and your birthday. That has more to do with genetics. Okay, so you're going to be asked to do the same type of thing on your homework tonight. You're going to read some statements and then answer negative, positive, or no correlation with those statements. Okay, do your very best. Good luck with that all.